are going to talk about circles that are not centered around the origin. Last class we did circles that were centered around the origin, 0, 0, and they had an equation x squared plus y squared equals r squared. But in today's lesson, it's totally different because these circles are not centered around the origin. So in the book that I'm in currently, I'm on page 151, but that might be different from wherever you are, and that's okay, no big deal. All right, so we're going to call this circles centered at h comma k. So remember when we did parabolas, and a parabola in standard form is ax squared plus bx plus c, right? There's no h's and k's in there. But then in vertex form, you have the h's and the k's thrown in. What is it? Y equals a times x minus h quantity squared plus k. And those tell you shift left, right, up, down, all that kind of stuff. Well, in a circle, h comma k tells you where the center of the circle is. There's no vertex in a circle like there is in a parabola, because h comma k tells you the vertex of a parabola. In a circle, h comma k tells you where the center of the circle is. All right? So, when a circle is centered at the origin, comma, the equation is x squared plus y squared equals r squared. And that's what we did last class. So for example, if you have your x and y axis, the center of the circle is going to be at 0, 0, and I'm going to do a radius of 2. So if I did that, I'd go to my center, I'd go to the right 2 units, I would go up 2 units, left 2 units, down 2 units, connect my points, and that's an example of a circle centered at the origin. All right, when a circle is centered, at any point, which we will call h comma k, we will have the equation open parentheses, x minus h quantity squared plus y minus k quantity squared equals r squared. And I'm going to make a note that h comma k is the center of the circle, also notice the equation subtracts h and k, so we must remember to change the signs. So, and you don't have to write this down. I'm just going to do this on a sticky note. Remember, a parabola or quadratic, either way you want to call it, is y equals a times x minus h quantity squared plus k. And if I asked you the vertex, we know it's h comma k, and we always had to change the sign of h, right? Because the formula subtracts h. So if your h is originally 4, you plug it in, it's going to look like x minus 4. And remember, that tells us the left and right. The k, it adds the k. So whatever k is the sign, you don't have to change it. This tells you up or down. Bless you. In a parabola, quadratic. But in a circle, it subtracts the h and subtracts the k. So you have to change the sign of h and k both. All right? Make sense? So let's look at an example. The directions say find the center, and the radius. And my problem is x plus 1 quantity squared plus y minus 3 quantity squared equals 16. So remember, your center is at h comma k. Anybody know what the center is? Minus 1 comma 3. Exactly. Because if we write the formula right under it, it's x minus h quantity squared plus y minus k quantity squared equals r squared. So your h would be originally negative 1 if it turned into a positive 1 in the problem. And your k would originally be positive 3. If we plug it in, it looks like y minus 3. So h comma k would be negative 1 comma 3. And then it also asks us for our radius. What would our radius be? 4. Because this is the radius, but it's squared, right? So we would have to take the square root of 16 to find our radius of 4. Yes. So if we had to graph this, which it didn't ask us to, but you're going to have to eventually. So it doesn't, your center is not at the origin, but that's okay. We still can do it the same. It's just, it's not, the counting, it's just not as easy, but it's not a big deal. So I am going to, let's see, my center is at negative 1 comma 3. Keep that in mind. At negative 1 comma 3. That's my, bless you, that's my center. And then if my radius is 4, I don't go up and down 4 units from the origin. I go up and down 4 units from my new center, right? So if I go to the right 4 units, I'm going to go, I like to come down to the axis and count. It's a little easier. And of course, this is hand drawn, so it's not going to be perfect. So I go 1, 2, 3, 4. 4 to the right, 4 up, 4 to the left, and then 4 down. Make sure you don't make those straight lines. It's a circle, so best you can without graph paper and a compass. Beautiful. Now, of course, there's a whole lot of more ordered pairs on that line, but we don't need to know any of them at this point just to sketch our circle, right? The radius at any point on this line is going to be 4 units. It's easy to find it when it's vertically or horizontally. This is vertical, this is horizontal. That's easy to find. Now, we don't go diagonal. We can go diagonal, but that's just more complicated. We have to do a little more work to find those points. But they still exist. It's just we don't need to do that if we're sketching. Everybody cool so far? Anybody have a question? Am I still waiting? All right, page 152. Example. Find the equation of the circle with the center at 2, 4 and a radius of 5. Well, if a circle is centered around the origin to write the equation, the only thing we have to know is the radius, right? And we can write the equation, x squared plus y squared equals, plug in the number the radius is and square it. But when your circle is not centered around the radius, to write that equation, we have to know the ordered pair of the center, and we have to know the radius to be able to write that equation. If we don't, then we have to find it. Did they give us the ordered pair for the center? Yes. Did they give us the radius? Yes. So do we need to find anything before we can write our equation? No. So if our center is at 2, 4, well, that gives us our h and our k, because it's h, k, right? And our radius is 5. So we have everything we need to write the equation of the circle. And x minus h quantity squared plus y minus k quantity squared equals, don't forget to square your radius squared. So that would be x minus 2. See how the center of the x value or the h value was positive, but now it makes it look negative? Make sure you square it. Plus y minus 4 quantity squared equals, if you want to do 5 squared now and then rewrite the whole thing, or you could just say 25. Be done with it. It asked us to write the equation. We did. We're finished. Coolio. Next example. Find the equation of the circle with the center at 6, -1. And the point 5, 2, which lies on the circle. Did I use lies in the appropriate way? It's not lays, right? Lies on the circle. Spelled it right and everything. I'm so proud. Okay, so we know that this center is not at 0, 0, so we can't do x squared plus y squared equals r squared, so we have to do the other one, the x minus h one. So to do that, we need to know the ordered pair of the center and the radius. Do we know the ordered pair of the center? Yes. Do we know the radius? No. We do know where the center is and then an ordered pair that's on the circle, so we could do this one in 2 ways. We could use the distance formula and find the distance between those 2 ordered pairs, and that would give us the length of the radius. Or we could do like we did last class, We normally don't plug anything in for x and y, right? But if we're trying to find the radius, we could use the point that's on the circle. We'll use their x and their y. So we will plug in a number for x and a number y, and we'll plug in a number for h and a k. So the left side of our equation will be all numbers. We could simplify it, and then that'll give us our radius squared, right? And then we'll have what we need to write the equation. So this is the longest one that we have to do, but it's no big deal. So I'm going to use, just make sure that your center is what you use for h and k, otherwise it's not going to turn out right. So the center is 6, negative 1. That's going to give us our h and our k.
Okay, so we're doing the formula, we're not doing quadratic formula?
Not quadratic. No, we're using the formula for the circle. Yeah, okay. And I'm not changing the sign because they said this is the center. When I plug it in the formula, it will change the sign, right? And then the ordered pair that they gave me, just the point on the circle, is 5, 2. And that's what I'll use for my x and my y. I'm looking for the radius. That's what I'm trying to find before I can write my equation. Make sense? Awesome sauce. Okay, so I'm going to write my equation x minus h, quantity square, plus y minus k, quantity squared, equals r squared. Again, normally we don't plug in stuff for x and y. That in the regular equation we don't. But since we don't know the radius, we're going to plug in numbers for x, h, y, and k. Simplify all that so we can figure out the radius squared. So for x, we'll use 5 minus 6, quantity squared, plus 2, and I'm subtracting k, which is also a negative, so it's minus a negative 1. You can write all that out. I will, but I have to remember that that's going to change it to positive 1, correct? Quantity squared. We don't know our radius. That's what we're trying to find. So let me simplify that mess. 5 minus 6 is negative 1 quantity squared, plus 2 minus a negative 1, that is a 2 plus 1, which would be 3 quantity squared, equals radius squared. Make sure you square that negative, get a positive. Negative 1 times negative 1 is positive 1, plus 3 squared is 9, equals radius squared. 10 equals radius squared. Now if I want to know my radius, I have to take the square root of 10, correct? It's approximately 3.2. But in the formula, is it necessary to go that step? No, because they're going to make me square it. So if I do 3.16, I'm going to have to square that again just to get 10. So you're just doing extra work, which you don't need to do. Do I have everything I need to know to write my equation? Yes. I need to know the center. I got it. I need to know radius squared. I got it. So now to answer the question, I'm writing the equation of the circle. So that's going to be x minus 6 quantity squared plus, open parentheses, y minus k, which k is a negative 1, so I'm going to go ahead and change that to plus 1 quantity squared. R squared is 10. Boom. So of the problems that you have to do for homework, that's the longest one, and that was no big deal. Easy breezy. Beautiful. Cover girl. One more quick example. You may have a question on this one? Does the point (6, negative 1) lie on the circle x minus 3 quantity squared plus parentheses y plus 1 quantity squared equal 16. So I got a circle. What's the radius of my circle? 4. Where's the center of the circle? 3 comma negative 1. Do I have to draw the circle and get a compass and graph paper and all that stuff, or use technology to see if this point is somewhere on the circle? Do I have to do all that? No, I can just do it algebraically, just like we did when we had circles at the origin, right? So how would I do that? Plug in this point. This is not h and k because it's not the center. It's just some point on the circle which we can use as our x and our y, right? Only thing we can plug in these spots are h and k. That has to be the center. But any other point in the circle is an x and a y. So for x, I'll plug in a 6. For y, I'll plug in a negative 1. And if I'll simplify the left side, and if it equals the right side, then yeah, it's on the circle, just like last class. So that will be 6 minus 3 quantity squared plus negative 1 plus 1 quantity squared equals 16. We don't know, and put a little question mark. So 6 minus 3, that gives me 3 squared plus negative 1 plus 1 is 0 squared. Does that equal 16? No, because it's going to be 9 plus 0 equals 16, and that is 9 equals 16, and it does not. So what's the answer to my question? Nope. Sad face. So the assignment that I'm about to give you, every problem on it is just like a problem that you'll find in your notes. Go back, read your notes. You'll find all your answers. Oh, like 6. Not that many. Anybody have a question? Probably not. Okay.